And welcome back. We're here for another set of notes. This one's going to be for Chapter 4.3, Solving Inequalities Using Multiplication or Division. Our essential question for today is, how can you use multiplication or division to solve an inequality? Let's go to work, guys. So we're going to go ahead and do one of our activities. I know we've bypassed those the last couple of sets of notes, but I think this one has some value that is important for what we're learning. So let me kind of get through the instructions and get you started, then you're going to finish this up yourself. The instructions say you're going to copy and complete the table, which is right over here. You're going to copy and complete the table, and then you're going to decide which graph, the one on the left or the one on the right, which one of the graphs represents the solution of the inequality, and then you're going to write what the solution of the inequality is, like x is less than 12, or whatever you think it may be. Okay? So let's go ahead and get started on this. You see that we have 4x is greater than 12. Now, I know you guys can do this in your head, but if you're a little lost on what to do, I want to take you kind of step by step what to do here. So in your head is fine with me. You're going to have 4x is greater than 12. And I'm going to plug in the value of -1 to begin with. So I have 4 times -1, and that's greater than 12. And so when I do that, I have, I'm going to swing over here, I have -4, is that greater than 12? So I end up getting -4 when I multiply this. And is -4 greater than 12? That would be a no. Let's try one more. This time we're not going to show the work. All I'm doing is I'm going to multiply the value of x, which is a 0. And so I do 4 times x, which is 4 times 0, and I get 0. So is 0, is it greater than 12? And again, this would be a no. So I want you guys to take a moment, finish this table out, decide what graph you're going to use, and then write down your solution of the inequality. Okay? I'll talk to you in a few moments. All right, looks like we are back in business. Let's see how you guys did with this, problem A of the activities. All right, when I have x equals 1, I do 4 times 1. I'm going to get 4. Is 4 greater than 12? I still have a no. When I put 2 in for x, I have 4 times 2, which is 8. Is 8 greater than 12? That is a no. Then I have 3. 3 times 4 is 12. Is 12 greater than 12? I think this one's an interesting one. It is not greater than, however, it is equal to, right? So this is a kind of an important problem here, an important value to put in here. It's still a no. It's still a no. But we're at the equal part. Let's see what happens when we put 4 in now. When I put 4 times 4, I get 16. Is 16 greater than 12? It is, so this is a yes. When I do 5 times 4, I get 20. Is 20 greater than 12? And that is a yes. So when I go ahead and I write I graph my inequality, I'm just going to use 3 numbers. The turning point was right over here when x is 3. So that's going to go here as 3. I'm going to put 2, 3, 4. And I'm going to have to decide, do I use an open circle or a closed circle? Well, since it is greater than, I'm going to use an open circle over here at the 3. And then it's going to go to the right, because if you notice, all numbers to the right of the 3 were a yes. And so it's going to go to the right like this. And so that would be my solution as a graph. Here's my solution as an inequality. So I'm going to have x. All solutions are greater than 3. So we're going to go ahead and move on to the next problem here. And we have -3x is less than 9. Or less than or equal to 9, pardon me. And so let's try this together and see how we come up, how we do with this one. So I have -3x is less than or equal to 9. And I'm going to put in the value of negative 5. That's right over here, right? Negative 5. So I have negative 3 times negative 5 is less than or equal to 9. So I have negative 3 times negative 5 gets me 15. Is 15 less than or equal to 9? No, it is not. So I'm going to put the 15 over here because when I do negative 5 times negative 3, I get positive 15. And 15, is it less than or equal to 9? That would be a no. Okay? We're going to try one more together. I'm going to do the negative 4 here. Negative 4 times negative 3 is 12. Is 12 less than or equal to 9? It is a no. So I'm going to give you guys a moment. Please fill out this table and then decide which of the graphs represent the inequality solution. And then go ahead and write down your inequality solution. We'll check back in here in a moment. Okay, let's see how you did on this problem. So how about negative 3? Right over here, negative 3. So negative 3 times negative 3 is 9. Now, is 9 less than or equal to 9? And the answer to this is a yes, because it is equal. So this is a yes over here. How about for the negative 2? When I do negative 2 times negative 3, I get 6. Is 6 less than or equal to 9? And that is a yes as well. It's a horrible looking yes, but it is a yes. Okay, how about negative 1 times negative 3? That gets me a 3. Is 3 less than or equal to 9? Yes. 0 times negative 3 is 0. That would be a yes. And 1 times negative 3 is negative 3. And that is a yes. So when I go ahead and I make this graph, I'm going to go ahead and have, when I graph this number line, apologize, I notice that it's right over here at the negative 3. That is the turning point. So I'm going to put a negative 3 over here. This would be a negative 2. This would be a negative 4. And since I'm dealing with less than or equal to, it's going to be a closed circle. So the closed circle is going to go right over here. And when I do this problem, it's going to be all solutions, all values of x that are greater than or equal to negative 3. That's all the numbers, negative 3, negative 2, negative 1, all of those were greater than or equal to negative 3. Those were all solutions, so it's going to go to the right. So my solution to this problem when writing it would be x is greater than or equal to negative 3. Now, I want to show you something that was pretty interesting to me. We're going to flip back to the last problem. Over here, notice that we had 4x is greater than 12. And so the greater than symbol is going to the right. Our solution is x is greater than 3, still going to the right. For B, we have negative 3x is less than or equal to 9. But our solution is x is greater than or equal to negative 3. I want you to store this little nugget in your head. We're going to come back to this at another time, but this is a very, very important thing to understand. There is a reason that that inequality sign flips. We're going to get to that later. So let's go ahead and move on to our notes, the crux of our notes. And so we have our multiplication division properties of inequality. And so we have, when you multiply or divide each side of an inequality by the same positive, note that it says positive number, the inequality remains true. So if I multiply both sides by the same positive, or divide both sides by the same positive, the inequality remains true, just like we did with equations. It's the exact same property. So let's look at it at an example. And I'm going to rewrite this over here in the left corner. If I have x divided by 5 is less than or equal to negative 3, I can then multiply both sides by 5 to get rid of that divided by 5 because that's the inverse. So I'm going to do 5 over 1 times x over 5 is less than or equal to negative 3 times 5. And when I do that, the 5's cancel out over here, and I'm left with x is less than or equal to negative 3 times 5 is negative 15. So that is my solution. And with these inequalities, especially with the multiplying and dividing, it's pretty important that you test this out. So we're going to go ahead and graph this. Again, my graph, the way I do it, it would look more like this. I'm using 3 numbers, keeping it simple. I've made negative 15 in the middle, negative 14 to the right, negative 15 to the left, I'm sorry, 16 to the left. And I'm going to do negative 15 is my number, and it's less than or equal, so it's closed. And it's going to go to the left because all values are less than. And a way of checking this is just plugging in a number to the left and see if it works. So for example, I'm going to pick my first multiple of that's going to be like a negative 5 multiple or a 5 multiple, because we have a 15, and well, we're dividing by 5. Let me make more clear sense with that. Since we're doing x divided by 5, I'm going to pick a value that can be divided by 5. So let's look at negative 20 over here. Negative 20 divided by 5 gets me negative 4. Is negative 4 less than or equal to negative 3? Yeah, it is. And if I go the opposite direction, and over here I pick the next multiple of 5 and I do negative 10 on the other side, it shouldn't work. So if I put the negative 10 over here and test it out, negative 10 divided by 5 is negative 2. Negative 2 is not less than negative 3. And it's a real quick check. You don't have to show the work. You can do it in your head, but it's a real quick check, well worth your time. All right, so let's look at our examples here. We have 3 examples. I want you to take a few moments to solve and graph the solutions, and then we'll go over these together, okay? Good luck. All right, let's take a look at your work, see how you did. Hopefully this made some sense to you. The way the problem is set up, they have n is divided by 3. I like it as a fraction. You don't have to write it as a fraction. I just am. So I'm going to put n divided by 3 is less than 1. And I know that if I multiply the left-hand side by 3 over 1, that cancels out. So I'm going to multiply this by 3 because I'm using the inverse operation. Instead of dividing by 3, I'm going to multiply by 3. So the 3's cancel out. I'm left with n is less than, and then 1 times 3 is 3. So there's my solution. N is equal to 3. Oh, sorry, is less than 3. Put my number line, and I have a 3 in the middle, a 4 to the right, and a 2 to the left. And I'm going to say it's an open circle because it's less than. And n is less than 3, so I go to the left. And again, if I check this, I pick any number to the left. The first one I come up with that's easy, well, whatever, you can use the 2 if you want. 2 over 3 is 2/3. Is 2/3 less than 1? Yeah, it is. If I go to the right, it is 4 divided by 3, 4/3. Is it less than 1? No, it's not. And so I know I have my inequality answered correctly. Let's try our next problem. I'm going to swap this over. It's something I tend to do, but you got to be very careful with this. I have m divided by 10. You'll notice that the big open part, the greater than sign, is facing the m, so I'm going to go ahead and flip that inequality sign like so. So it's still facing the same value, the m divided by 10. And then on the other side I have negative 0.5. And so at this point, if I'm dividing by 10, I'm going to have to multiply by 10 to get rid of the division. So I'm multiplying both sides by 10. And when I do that, these cancel out, and I'm left with an m is greater than are equal to negative 0.5 times 10 is just going to be negative 5. I can go ahead and graph this now. When I graph it, I'm going to put my negative 5 in the middle, a negative 4 to the right, a negative 6 to the left, and it's going to be a closed circle because it's greater than or equal to, and since it's greater than or equal to, it's going to go to the right. All solutions are to the right, including the negative 5. So I could put a negative 5 in for m, and negative 5 divided by 10 is negative 0.5, which is equal or greater than negative 0.5. If I continue to go to the right, the next number I could use that would make sense, well, I could do negative 4. Negative 4 tenths is greater than negative 5 tenths, because remember, negative 0.5 is negative 5 tenths. If I went to the left, I could try negative 6 over 10, which is negative 6 tenths, which is not greater than or equal to negative 0.5 or negative 5 tenths. Again, I strongly recommend you take that extra 5-10 seconds to check your work. It really, really will come in handy because these inequalities are going to possibly get confusing to you, and you don't want to make mistakes because of not checking your work. Okay, be as smart about this as you can. All right, and checking your work is always smart. I see the 2/3 p is on the right-hand side of the inequality sign. I want it on the left-hand side, so I'm going to rewrite this as 2/3 p, and since I have the little part of the inequality sign pointing to the p, I'm going to flip it so it does the same thing, and over here is a negative 3. To get rid of 2/3, I've got to multiply by the reciprocal, 3/2, and I multiply this. I'm going to make this negative 3 over 1 and multiply it by 3/2. And when I do this, the 3's cancel and the 2's cancel, leaving me with p is less than. And then I can't cancel anything out, so I have negative 9 over 2, or you could have p is less than negative 4.5. Again, I don't mind having the decimal. In fact, I almost prefer having the decimal if at all possible. So I'm going to go ahead and graph the decimal version. I prefer it, but you can see it either way, as long as the decimal is terminating. And so I'm going to put the negative 4.5 over here. I'm going to make this negative 4. I'm going to make this negative 5. And it's going to be an open circle, since we are dealing with a p is less than. And since it's less than, it's going to go to the left. And again, you can check this work out. I think you guys get this at this point, how to check the work. So we're going to move on. I know the time is going by kind of quick, so let's move on. Okay, now we're going to have a multiplication inequality. So we have, in this case, we have 6x is greater than negative 18. I know you guys are more comfortable with these, so this should be pretty easy for you. So I'm going to divide both sides by 6, and I get x is greater than negative 3. And I can go ahead and graph this. I have a negative 3 in the middle, negative 2 to the right, negative 4 to the left. So when I graph this, it's open because it's greater than, and it's going to go to the right. And again, I can switch this out at I can try any of the solutions to see if my inequality is correct. So if I pick a number to the right of the negative 3, the negative 2, 6 times negative 2 is going to get me negative 12. Is negative 12 greater than negative 18? Yeah, it is. Again, I could use the negative 4. So I'd have 6 times negative 4, which gets me negative 24. Is negative 24 greater than negative 18? No, it's not. So I know I have the correct answer. So let's go on to our problems to try out. You have 3 problems, 4, 5, and 6 to try out. Go ahead and solve them, graph them, and we'll check in just a minute. And we're back for our last 3 problems of today. You heard me correct. We're doing just these 3 more problems. We're going to stop the notes at this point. I know that you're getting kind of full, so I think we were going to stop. So let's finish these last 3 problems, see how you guys do. So I have 4b is greater than or equal to 2. And I want to undo this. So undoing, multiplying, I'm going to use division. So it's my inverse operation. And I end up getting b is greater than or equal to 1/2. Or you could say b is greater than or equal to 0.5. Either way is fine with me. I'm going to go ahead and graph it. And with my graphing, I'm going to use the decimal. It's easier. So I have 0.5. And I'm going to go ahead and put 0.4 or 6 here and 0.4 over here, just to be a little different, saying that it's okay to go by tenths as well. And for this, it's going to be a closed circle because it's greater than or equal to. And it's greater than or equal to, so it's going to go to the right. So hopefully this is what you got for that problem. For number 5, we have 12k is less than or equal to negative 24. And we're going to divide both sides by 12 because I'm doing the inverse of multiplying by 12. And these cancel out, and I get k is less than or equal to negative 2. And I can go ahead and graph this. I have a negative 2 in the middle, negative 1 to the right, negative 3 to the left, and I'm going to use a closed circle because it's greater or less than or equal to, and it's going to go to the left. And again, I can check my answer by picking a number to the left to see if it works. If I do negative 3 times 12, I get negative 36. Is negative 36 less than or equal to negative 24? Yeah, it is. Just to make sure I didn't do a mistake, I'll try a solution on the opposite side that is not a solution, negative 1. Negative 1 times 12 is negative 12. Is negative 12 less than or equal to negative 24? No, it is not, so I know I have the right answer. And now we are on to our final problem for the day. I have negative 15 is less than 2.5q. I'm going to go ahead and rewrite this as 2.5q is greater than negative 15. And then I'm going to divide both sides by 2.5. And when I divide, the 2.5s cancel out, giving me q is greater than. And if I do negative 15 divided by 2.5, feel free to use your decimals if you didn't the first time. You would get negative 6. So when I graph this, I'm going to have negative 6 in the middle, negative 5 to the right, negative 7 to the left, and I'm going to have, let's see, I'm going to have a open circle because it's greater than, and since it's greater than, it's going to go to the right. That means all solutions are to the right, and again, I can check this out. I can plug in the negative 5, so negative 5 times 2.5 is negative 12.5. Is negative 12.5 greater than negative 15? Yes, it is. I could also try that with the negative 7. Negative 7 times 2.5 gets me negative 17.5. Is that greater than negative 15? No, it is not. So I know I've graphed this correctly. So that concludes today's lesson. I'm going to make this the part 1 lesson for 4.3. We will continue this at another point. Hopefully you found this to be helpful, and best of luck with your next assignment.